a phenylprop 2-enoic acid, phenylpropanoic acid, or also known for its common name, cinnamic acid. Cinnamic acid is a monocarboxylic acid bearing a phenyl substituent at the 3 position. It has 9 carbons, 8 hydrogen, and 2 oxygen with a formula of C6H5 CH double bond CH COOH. Cinnamic acid is one of the compounds that belong to phenylpropanoid pathway that are precursors of flavonoids and lignans. Cinnamic acid is a precursor to the sweetener aspartame via enzyme catalyzed amination to give phenylalanine. So this compound, or the hybridization of this compound, is a sp2 hybridized, and it has 17 sigma bonds and 4 pi bonds. Cinnamic acid has a COOH functional group, which is a monocarboxylic acid, and the formal charge of this molecule is a hydrogen, oxygen, and carbon. And in hydrogen, it has 1 valence electron, 1 bonded electron, and 0 unshared electrons. So it has a 0 formal charge because all chemical bonds are equally shared. In oxygen, it has 6 valence electrons, 2 bonded electrons, and 4 unshared electrons. So if we subtract that, it has equal to 0 formal charge because all chemical bonds are equally shared, and it has a lone pairs, and it has a molecular orientation or molecular shape of trigonal planar because it has a 120-degree angle here. So this is categorized as trigonal planar as molecular orientation and molecular shape. So this is a trigonal planar. To determine the polarity between the atoms and dipole moment, first we need to get the electronegativity of each atom. So first is the carbon, oxygen, and the hydrogen. So the electronegativity of carbon is 2.55. The oxygen has 3.55 or 3.5 rather, sorry. And the hydrogen is 2.2. So we will make an example here in the functional group, the carboxylic acid. So carbon has a 2.55 electronegativity, and the oxygen has 3.5, both 3.5. So, and the hydrogen has a 2.2. So in these two atoms, you can see that carbon has a lower electronegativity, so it would be a partial positive, and this would be a partial negative. So same with this, has a partial negative also. So the dipole moment will be crossing the carbon to the center of both oxygen. So and because here this is a positive, or this is a partial positive, this would be the head of a arrow, and because this is the negative or the partial negative, this would be the tail of the arrow. So in this functional group, the dipole moment of these atoms are this. You see the arrow. Additional example is hydrogen and carbon. Hydrogen has a 2.2 electronegativity, and carbon has a 2.55 electronegativity. So this would be a partial positive. This would be a partial negative because hydrogen has a lower electronegativity than the carbon. So as what we make or done in this functional group, the partial positive will be the head, and the partial negative be the tail. So that is the dipole moment of the atom. So this is the presentation of cinnamic acid in guava fruit.